Welcome to the course on wireless communication systems for BTech Electronics and Communication Engineering final semester. Wireless communication system is among the fastest growing domains in the communications industry. Wireless communication systems has become an essential part of our electronics and communication study and is a core subject for your BTech degree. Coming to the syllabus, Module 1, 1.1, the first part of our syllabus, we will get ourselves introduced to wireless communication systems. We will be studying a brief history of wireless communication systems from 2G to 6G. We will be traversing across the different technological advancements from 2G, then to 3G, 4G, 5G, and we will see the basic differences or what is the advancements, what are the changes that happened since 2G came into existence. From then, we will study about wireless local area networks, Bluetooth and personal area networks, broadband wireless access, WiMAX technology, wireless spectrum allocation, and various other standards used in wireless communication systems in this particular lecture. All It all began in 1880 when Hertz demonstrated that electromagnetic waves could be used to transmit information from one point to the other wirelessly without the use of any kind of uh, wires. The first experiment, which demonstrated that an oscillating electric charge could radiate electromagnetic waves. 1880, Hertz's initial demonstration of practical radio communication. The energy of these waves is due to the kinetic energy of the oscillating charge. Here, in this experiment, Hertz demonstrated that he has used two parallel plates of a parallel plate capacitor, one with a positive charge, the other with a negative charge, and we observed that an electromagnetic wave is generated from this point to the and it travels across a particular distance. The mathematical modeling of this particular electromagnetic waves can be done using Maxwell's equation for free space. Let us look into the Hertz experiment in detail. The experiment arrangement consists of two spherical plates A and B kept at a distance of around 60 centimeters from each other. The metal plates are connected to two polished metal spheres and by means of metal rods. Using an induction coil, a high potential difference is applied across the small gap between the spheres. When a potential difference was applied across these two spheres, we came to know that electromagnetic waves are generated and it could be received using a receiver coil. So let us look in detail about the Hertz apparatus and his experiment. We have two parallel plate capacitors, one A and one B. We have 2 points connected with a metal rod S1 and S2. When a high potential difference is applied across these two parallel plates, a sinusoidal wave is generated, an electromagnetic wave is generated, and it could be received in a receiving loop with two spark balls separated with a small air gap, a micrometer air gap. This was the first experiment which demonstrated that electromagnetic waves could be used for communication from one point to the other. The first wireless networks were developed in the pre-industrial age. While looking into the brief history of our wireless communication, previously there were so many other means of communicating from one point to the other. Initially, we used smoke signals. There were doors which were used for sending letters from one point to the other. Once upon a time, we used doors, and it's very famous for that. So, previously, we had tried different methods of communicating wirelessly from one point to the other. Now, we are using advanced technology so that wireless communication has become highly reliable and highly useful and has become a part of our everyday life. The first systems that we developed for transfer of information were smoke signals, torch signaling, flash mirrors, signal flares, or semaphore flags. The first practical use of radio communication was demonstrated in the year 1897 by Marconi, where he established a transmission path from a land-based station to a tugboat which was around 18 miles apart. Considering 1897, around considering 1897, transmitting an information from one point to the other, that is 18 kilometers, 18 miles apart, was a big achievement. This was the first initial apparatus that was used by uh, Marconi to demonstrate his wireless transmission system. There is a transmitter at the center and a receiver with a pole that is supporting the wire. This is the antenna. This is a picture taken from Wikipedia, which the first steps of development of wireless communication systems. So, as per our syllabus, we need to study about how things changed from 1G to 5G. The first generation of cellular systems were primarily analog. We used analog signals, frequency modulated signals, to transmit information from one point to the other, and was primarily used for military applications. This evolved around 1980s, early 1980s. From then we shifted to 2G, where global systems for mobile was developed as a world standards for wireless communication. And the primary change that happened from this primary change that happened from this to this was analog to digital. And when the technology changed, it became more popular, and the first generation, as I've told you already, was primarily concentrated on developing military applications and were used by the army. But when it came to 2G, it started becoming more and more popular. Common man started using mobile communications. From then, from 2G to 2.5G, then 3G. 2.5G was an intermediate stage between 2G and 3G. There was a change in technology from voice communication to data communication. Primarily, the concentration shifted from voice and text messages to data communication. We developed a system called as General Packet Radio System. From then, as we evolved from 2G to 3G, there were changes in technology. Edge came into existence. Edge, where Edge primarily meant enhanced data rates for GSM systems, where the data rates started, the data requirements and the data rates started increasing more and more. From then 3G to 4G, there was a long-term evolution technology, LTE technology, where we started shifting from Internet of Users, connectivity between users, to Internet of Things. And almost all, so many other equipments started getting connected to the internet, and there was a cloud processing of data. Machines started getting connected to the net, and we started accessing machines through cloud mechanisms. From 4G to 5G, things have changed further drastically, from Internet of Things to Internet of Everything. Almost every machine, every human being, everything in the world started getting connected to the cloud, and we started using internet for controlling machines and so many other various kinds of applications. As we see, the requirements for data rate, requirements for transmission, speed, the requirements for bandwidth, everything started increasing as we pass on from one generation to the other. We will be studying two important definitions which we require to understand the change in generations. In order to understand the history of evolution of wireless communication systems, we will be studying two important definitions. The first one is about the spectral efficiency. Spectral efficiency is defined as the log to the base 2, 1 plus received signal power by interference power plus noise power in terms of bits per second per hertz. Another definition that we will be studying is the area traffic capacity. The area traffic capacity is defined as the product of cell density, available bandwidth, and spectral efficiency. As we go across the slides, we will come to understand what is cell density, what is the bandwidth requirements, and we will be understanding in depth what spectral efficiency means. So now we'll start understanding the evolution of wireless communication systems from the first generation of commercial deployments of mobile systems. In the year 1891, witnessed the birth of first commercial deployments of first generation mobile cellular standards such as Nordic mobile telephone in Nordic countries. So the first commercial deployment of mobile phones or mobile communication or wireless communication started in 1891, and it was called as first generation of wireless communications. The first generation 1G standards are called the analog standards since they utilize analog technology, typically frequency modulated radio signals with a digital signaling channel. So in the first generation, primarily we used analog signals, ordinary sinusoidal signals from modulated using frequency modulation. Then came the second generation. The global system for mobile standards were developed, which was formalized in the year 1992, and suddenly and rapidly has been rapidly adopted by billions of cellular users for voice communication. With the advent of global system for mobiles, the number of users started increasing drastically. All of a sudden, there were more number of users because it was more convenient. In this particular slide, we will be looking back into how we came into a world where we will be deploying advanced technologies like artificial intelligence in wireless communications. So we'll be traversing across all the technological changes that happened from 2G to 6G. In 2G, we started using digital systems for voice communication. Primary importance was given to voice communication. The technologies that became popular during the second generation was time division multiple access and code division multiple access. From then, when we moved towards the 3G standards, from voice communication we started concentrating more on data communication, internet technology, IP, Internet Protocol, and wireless CDMA. Universal Mobile Telecommunication Systems, UMTS, was developed during 3G. Another important change that happened during 3G was the development of 3GPP, Third Generation Partnership Project, which was primarily designed to understand or to develop standards of communication worldwide. So that change from 2G to 3G has become from voice to data. Then from 3G to 4G, we call it as long-term evolution. 3G to 4G, we started developing several other technologies like MIMO, multiple input, multiple output. We started developing other modulation techniques like the multi-carrier modulation techniques like OFDM, orthogonal frequency division multiplexing, or orthogonal frequency division multiple access. This improved the modulation techniques and this improved the communication over different user equipments or different things that was connected to the internet. So same way, from 4G we started developing 4G. We started changing from Internet of Things to Internet of everything. Almost every machines, everything that is being used by human beings started getting connected to internet. They started developing systems where machines can be automatically operated by, accessed by remote, can be operated using wireless systems. So this forms the backbone of every industry, from communication industry to every industry, wherever we require production, wherever we require changes, everything, machines and everything. So from machines and others, we started shifting from 4G to 5G. In 4G to 5G, Internet of Things to Internet of everything, more number of equipments, more number of machines, more number of things became connected to the cloud. What happens when more number of things are connected to the cloud? Our data requirements, our bandwidth, our all the other infrastructural requirements started increasing drastically. So we need more facilities. So 5G became essential. From 5G to 6G. 5G was deployed. The first commercial deployment of 5G was in 2019, and now 5G has been deployed in almost every country and every places we have 5G. Most of you are using 5G mobile phones. From 5G to 6G. The change from 5G to 6G was the advent of artificial intelligence. Instead of connecting and simply connecting all the machines to the internet, machines started becoming intelligent. They started thinking of their own and they started working according to the conditions. They are able to revamp, they were able to make themselves ready to work without or with very less human interference. 6G deployment is going to be another big change that is going to bring human life to a different state of different standards or different state of living. People are going to live in a higher standards by using more automated machines, machines that could think or machines that could do the required process like human beings are doing. So this is how the technology is changing rapidly from 2G to 6G. So this is a tabular representation of the data rate requirements. The first one shows the tabular representation of data rate requirements from 2G to 5G. When in 2G, there was in 3G we were using 384 kbps. When it came to 5G, our requirements became 1 Gbps, and for 6G it will be 1 terabytes per second. This is a tabular representation of comparison of the evolvement of wireless communications from 2G to 3G, where we had the data rates increasing to 200 kbps. These were the mobile phones that were used in our previous generations, where these phones had only two requirements: making phone calls and receiving text messages. Now, today these phones have become obsolete because today our primary requirements have completely changed from making phone calls to using internet, getting connected to the world, controlling machines. The requirements are listed, are innumerable, are infinite. So as we go on, our equipment and our requirements, our infrastructure, our everything is changing very, very fast. That is why in the introduction I told you that wireless communication systems are among the fastest growing domains in communication and all other related industries. So with this we'll conclude our first introductory lecture. In the coming lectures, the next lecture, we will see in detail about the technological developments that led to 6G. We will see each of these generations, 2G, 3G, 4G and 5G in detail in the coming lectures. Thank you for attending this lecture. Thank you very much.